So, good afternoon. Question number 3. Design an Armstrong FM generator to generate an FM carrier with a frequency of 96 MHz and delta F frequency deviation of 20 kHz. A narrowband FM generator with carrier frequency of 200 kHz and adjustable frequency deviation, that is delta F, in the range 9 to 10 kHz is available. There is a bandpass filter with any center frequency and only frequency Dopplers are available. Hint is take FLO local oscillator frequency as 9.8 MHz. So coming to the solution for this, we have given all these values: carrier frequency and deviation and local oscillator frequency and FC1, delta FC1, all these are given. Okay. As we saw in the previous formulae, these are the formulae here. Considering these formulae, you can find FC2, okay, FC2 by using this formula, FC2, N1, FC1, okay, and the same here 64. N1 is given as 64, so you will get delta FC2 as 625. In the same way, FC2 formula, by using this formula FC2 N1 FC1. In the same way, delta FC1, this is the formula. Okay, so all these values you will get by using the formula. Okay, this is about question number 3. And coming to question number 4, superheterodyne receiver. Okay, we are talking about here superheterodyne receiver. A radio receiver used in AM system is shown. The mixer translates the RF received frequency to a fixed intermediate frequency of 455 kHz by using a local oscillator FLO. The broadcast band frequencies range from 540 to 1600 kHz. So this is the block diagram of receiver, superheterodyne receiver. And the question is, determine the range of tuning that must be provided in the local oscillator. When FLO is greater than FC, FLO is less than FC. Explain why the usual FM radio receiver uses the first case. Okay, there are two cases now. We have the formula here: FLO minus FC equals FIFF, intermediate frequency. We have here two conditions: FLO is greater than FC, FLO less than FC. When FLO is greater than FC, then FIF equals FLO minus FC. Okay, here is the modulus. When we decide FLO is greater than FLO minus FC. When FLO is local oscillator frequency is less than carrier frequency, then intermediate frequency equals FC minus FLO. These are the two conditions. We will apply both. FLO minus FC equals 455 for AM and FLO equals FC plus 455. This is up conversion. Therefore, FLO tuning range is 955 up to 2055 kilohertz. As you substitute here FC, the FC value, you will get this one. Then when FLO is equal to FC minus 455, then the tuning range becomes 85 kilohertz to 1145 kilohertz. Okay, now in the first case, FLO ratio 2055 kilohertz by 955 kilohertz equal 2.07, and for the second case, FLO ratio is 1145 kilohertz by 85, that is 13.47. So comparing these two values, it is much easier to design an oscillator that is tunable over a smaller frequency ratio. So this FLO ratio, the first one, is most appropriate and used to design a receiver. This is about question number 4. Okay, and this is question number 5. What is question number 5? This is question number 5. For it is also a receiver, superheterodyne receiver. For up conversion, all the values are given here. FLO is given as 1355 and RF is given as 800 kilohertz, and here all the values are given. Let's see the question here. See here, the local oscillator frequency is given as local oscillator frequency is given as 1355 kilohertz. Determine the intermediate frequency, upper side frequency and lower side frequency for an RF wave that is made up of a carrier and upper and lower frequencies of here the given frequencies, upper and lower frequencies, and respectively. So what are these values? Carrier frequency is 900 kilohertz, upper and lower frequencies are 905 kilohertz and 895 kilohertz respectively. So coming to the solution for this, for up conversion, FLO equals RF plus FIF. So IF equals, you need to find IF, FLO minus IRF. Substitute these values, you will get 455 kilohertz for up conversion, intermediate frequency value. And for upper sideband and lower sideband. For upper sideband, FLO minus F IF LSB. LSB. So 1355 minus 895. It's given. So it will be 460 kilohertz. And for LSB, FLO minus IRF USB. USB is given as 905. So substitute here 1355 kilohertz minus 905, that is 450 kilohertz. This is intermediate frequency for upper side. This is intermediate frequency for lower side. This is standard IF 455. This is the center frequency. Okay. This is about question number 5. Thank you. We finished sheet 5. Next week we will start information theory. Thank you.